let's record. So we're doing this percentage increase or decrease, but as a percentage of the original amount. Okay, so that was your homework to go through that. Are you all feeling like, yeah, got that? Okay, that bit. Right. So you've got this percentage increase is the increase over the original times 100, or if it was a decrease, it's the decrease over the original times 100. Now, what's common for both of those things? Is it?
The increase and the decrease is always on top of the original.
Yeah, so the original is the denominator. So it's the numerator that gets changed. So what I'm trying to do now is I'm trying to get you to consider a slightly different way because of the next thing we're going to do. That's all. Right? So if we were to have a look at these couple of questions then. So the number of people on a bus, it tells you increases from 25 to 30. So the increase therefore is 5, right? So we would do 30 minus 25, easy enough. So how do we work out the percentage increase, Daniel?
So you do 5 on the top and you do 25 on the bottom because
Right.
that's from where it
Because
came.
that's the original.
And then you do 10, which is 0.2, and then you times it by 100.
So that's 0.2 times 100 equals
20.
20%.
That means that the percentage is 20%.
Okay, so it's a 20% increase. Okay, cool. If we do the next one, so decrease, right? So this thing decreases from 800 to 780. The decrease is here,
20.
20. Therefore, we do
20 divided by the original, which is 800.
okay.
Which gives you 0.025.
So that's 2/8. No, 2/80ths. Yeah, which is, sorry, what did you say again?
It said
0.025.
0.025. And then
Yeah.
multiplied by 100.
Multiplied by 100 is
2.5%.
2.5% decrease. Okay, now what I wanted you to have a think about is if you don't use the increase or the decrease as the numerator, but the amount you have, okay, so one of those two, right, so basically we have the original and then we get a new amount. So if we use that amount as the numerator, right, and we do it, the question is, what will you end up with? So, for instance, with this question here, what would that become if we didn't work out the increase? What would it be as a fraction? So instead of 5 over 25 times 100, we would have what over 25 times 100?
30 minus 25?
No, just
30.
Just 30. Okay? 30 times 30 divided by 25 times 100. Okay? You chewing gum?
No.
Chewing something. Okay, if we do 30 divided by 25 times 100, what do we get?
120%.
That's the math to do it.
Yeah. Because 30
It's
divided by
120%.
Okay.
Yeah,
So
120.
we find the answer as 120%.
And then
Now-
we wait.
So, the question then is, can you make that link? What do you notice? Sushi?
If you can remove 100, then you get 20%.
So, that look, 120% is basically the same as saying you've increased the amount by 20%, yeah? So, that is something that is important for you as we develop. So 120% means an increase of 20%. So what that means is we don't actually have to do the subtraction or the addition at the beginning. Make sense? Yeah? Why is it more complicated? There's less
More
things to do.
complicated, but it's just
There's less to do.
method.
Right? So, what about though the decrease? What happens there? So this time we would do not 20 over 800, but
780.
780 over 800 times 100. And what answer do I get? Okay. 0.
Times 100.
Yeah, which is
97.
97.5. Okay. So can we do the same thing with this as well? What do you notice? What's the link coming?
It's 2.5% less than 2.5 less than 100.
Yeah, exactly. 100% minus the 97.5% that we got will leave us with 2.5%. So we know that 97.5% is a 2.5% decrease. Okay, so that one, Daniel, is a little bit more complicated to interpret at the end. But actually, this method here is what we need to really get into our heads. Because, alright, because this method, okay, is the same thing as finding one amount as a percentage of the other. Alright? So, basically then I can interpret this in a different way. I can say 30 is 120% of 25. Yeah? I can say that 780 is 97.5% of 800. That can then be interpreted as an increase or a decrease. Okay? Have you ever done finding one amount as a percentage of another?
No.
Big figures, a lot of you. How many of you have worked out your percentage score for your tests?
Oh.
No. So you've only done it, what, like 1,000,000 times each?
Yeah.
Yeah?
Yes.
You score 58 out of 20, 58 out of 70. How do you work out your percentage?
50 divided by 70 times 100.
Yeah, 58 divided by 70 times 100. If I had to, does it make sense to talk of that as a decrease?
Add it up, I
No,
guess.
it's the same process, it's the same maths, but you don't really decrease anything. Although what you could think of it as is, I have the potential to score full marks. What I actually scored was less than that, so it's a decrease. Right? In a test or anything, that's why it's not possible to get over 100%, because you can't increase on what's available. But we have exactly the same method then for working out percentages increase and decrease. There's no need to have a different method, is what I'm trying to get at. Make sense?
Yeah.
Okay, so can we move on then? Are you happy? Alright, let's move on to a new objective. Okay. So I would like you to write that down. Everyone okay with that? We happy with what we've done? Tell me if you don't want to move on just yet. No one said anything. Okay. Right. Our new objective now then is be able to calculate a reverse.
I tried that.
Yeah, good. If you've already tried that, that's good. Okay, ladies and gents, so this is an example of a reverse percentage. Okay, so basically, you're not asked to find the percentage. That's what we've been doing before. So we've just discussed the percentage increase and decrease is just finding a percentage again, like normal, and then you have to interpret it at the end. This time, however, we're not given both values. We're given one value, the new value, and we're told what happened in terms of percentage. All right. So you all know, you go around sales in shops, right? You know that this thing is on sale. Quite often you'll see the old price, you'll see the new price. Did you know, by the way, that if you check their prices, get your calculator out, check the price, if their price is higher than it should be based on the advertised percentage, you can go and say, I want it for this price, and they have to give it you.
They do?
You know I did that.
If they advertise it as 25% off, and then the price they've got it on for is not 25% off, you can say this is the price it should be.
You know
Yeah.
Don't they have something in the below which says conditions apply or something?
If they advertise it as 25% off, that's it. You know, if they advertise it as that,
I remember because Interdiscount, there was this website where you can get like really cheap stuff.
yeah,
And well, Interdiscount was like, there was a link for Interdiscount, there was this really cheap thing.
Yeah.
So I went to discount, but it was actually in the actual shop, it was 50 francs more, and I told them there's
Yeah.
something going on. And they
No,
were like,
but they
Well,
can
really
because they
badly.
have in the shop they have to pay people. Online they don't have to pay people. That's why it's more expensive in the shop.
I think it was into discount or somewhere. You have coupons and you scan them and
Yeah.
it tells you the price. It was saying like iPhone 6s at the start, it was 500 francs
Yeah,
on the website and on the poster.
yeah.
But when you did it, it was like 700 francs.
Oh, right.
And my father's friend, he sued into discount
Oh,
for
really?
lying,
Oh, wow.
and he got 2 iPhone 6s.
Oh, did he?
Yeah.
Go for it, guys. Look through the coupons. Right, okay. So this is what we've got to do now. Any idea what you would do, Kim?
I know this is the worst way of doing it,
Really? Okay.
but I kind of like, I was like 81. I think you would do that because you would take away 9 francs from it.
Right.
And then I said, what if it was 90 francs to start with? 10% of 90 is 9, so 90 take away 9 is 81. So I just kind of like.
That's not the worst way of doing it. That sounds fine to me.
Really?
Yeah.
Oh,
Right. Basically then, if we were to write down this a bit mathematically,
Oh no.
right, we know that there was a price. I'm going to call that X because it's unknown. Okay. What we have to do is know that that is a reduction of 10%. So what we're going to do is find 90% of it.
So isn't 90% like the 81 CHF? I have a.
So we've got original, so we've got the new price is 81 over the original this time is equal to, sorry, I should put the times 100. Right, this is what we've just been doing. Times 100 will equal 90. Is that right?
But I have like a.
Sure?
Can I just.
Yeah, go on.
So in my opinion, I'm not sure if this is correct, but I would do 81 divided by 100, and then times it by the percentage that people wanted to do.
Okay, so this is what, that's what I kind of expected somebody to say actually. What, right, the problem that comes is, Kean did the right thing. It's quite an obvious one. If I could have given you a much harder one. It's quite obvious in that it seems to make sense that, oh look, 81, that was probably 90, and 10% of 90, take it off, makes 81. Alright, but what people do, they make the mistake, is if I start with the original price, okay, and I decrease by 10%, I get the new price. Now what's not true is take the new price and increase by 10% to get the original. This is not true. Okay? This is not true. Any ideas why you cannot do that, Izzy?
Well, because if you're finding 10% of the new price, it's not finding, because it's the new price, it's not the same as the old price, which means you're not finding the right.
Yeah, that is spot on. That's exactly it. If you found 10% of what the new price was, after a decrease, 10% of that is smaller than the 10% of the original price. So you can't just go, oh, work out 10% and add it back on. Yeah? So in this case, what we have to think of it is this equation, right? So like you've been using before, right? And we can rearrange this. So I'm going to get rid of the times by 100 and say, well, it's 81 over x will be 0.9. Are you happy with that? Because it was a 10% reduction, so I've got the 0.9. That's how I know that. Is that all okay with you?
Yeah.
That's why we did it before. Yes, Susie?
I was thinking of it in a different way, like.
Can we not?
Okay.
Can we come back to that then? Yeah. So then what we can do, using our rearranging skills, is what? What do you think? So if we've got 81 divided by something equals 0.9, how can I deal with that? Well,
You times 100.
that doesn't help. I just undid the times 100. Ishram?
81 divided by 0.9.
Okay, so
Because 9.
yeah,
19.
I can multiply by x both sides. This is our rearranging we've done before. So it's 81 equals 0.9x. And then I'm going to divide by 0.9 to get 81 divided by 0.9 equals x. Okay. So what we have to do is actually divide by the number. Alright, not times by the number. Okay. Yeah, question?
But at the very start, if you did 81 divided by x equal times 100 equals 90.
Yeah.
Where did you get the 90 from?
Because if 81 over x times 100 is 90, if I don't do the times 100, what will the answer be?
No, but like, where did you get the 90 from? Like, if you're just starting over.
Because it's a reduced by 10%,
Mhm.
means, remember that method we had at the end of the last bit was, therefore,
100%.
find
1x.
90%.
Okay.
Reduced by 10% means
Okay.
find 90%.
I have another solution that does not involve any of x's.
Okay?
So basically, it's like finding the 1%. So now we know that this is 90%.
Yeah?
So if that means if we divide it by 10%, then that will
Divide
give
what
us
by
9%.
10?
Divide 90% by 10, so which is like dividing 81 by 10. We will get 8.1,
no,
which is
no.
9%. And if we divide that by
No,
9,
no,
we get 1%.
Not. That's what I've just said. It's not. You cannot find 10% of 81 and add it back on. It doesn't work.
It's not 10%. So if you have to
Or
divide.
90% or anything. I cannot use the 81 and find any percentage of the 81. I can't do it. It's different.
Exactly. We know that there's 100%, which is x,
Yeah?
and then there's 81%, which is 90%. So we already take
Okay, I get what
81%
you're
less than
saying.
90.
Yeah. But that's the same thing, really.
Yeah, but
But
I find 1% and then multiply it by 100. basically.
No, you wouldn't multiply it by 100, would you?
No, if I find 1%, then I would
Sushi's
multiply.
method, I think what he's trying to say, the final bit is not, it's along this line, less algebraic, but what he's saying is, if 81 is 90%, basically what we're saying, okay. If you then say, well that's the thing, 81 is 90% because it was a 10% reduction. So if we then find 81 divided by 10, that would equal
8.1, which is 9%.
so 9%. So that's 8.1 equals 9%.
Now divide that by 9 and you get 1%, and then
8.1 divided by 9 is 1%, and you can multiply then up to. It's the same thing, just a simplified, longer way of doing it. Right? So you can do that, but the big thing is to realise that you cannot just find 10% of the other one. Go on, find.
It's basically sushis, but it's kind of simpler. It's just 81 if it's 90%. You're trying to find 81 by 9.
Yeah.
And then you have 10% of the original one.
Yeah. Yeah. So it's the same thing again. Alright, so really all at some point you'll have to get happy with these decimals and x's and things because it's an algebraic way of solving, but we'll have another look. Alright, this afternoon. Well, not this afternoon, after break. Okay?
No, it's after lunch.
It's after lunch, is it?